negative 8 there. So negative infinity to what? Round all the way? Ooh. What?
I'm just confused.
By what? This is the starting point of your interval, and this is the ending point of your interval.
I thought it would, wouldn't it like continue from the bottom?
Yeah, but we're only describing what? We're only describing the x values. So don't worry about it's going up forever, but there's a boundary. There's a vertical asymptote. You guys get it? Okay, well, what about this interval here? Interval of increase or decrease? Increase from where to where? Yeah? Yeah.
So negative 5, yeah, to round bracket, right?
Yeah.
To 0.
Yeah.
Wait, that'd be the closed off bracket, right?
Well, is it round or square?
No, it'd be square. Sorry, square.
Is it increasing or decreasing right there?
No.
So, do we include it?
No.
Good?
Round is when it's equal.
Round is when it's not equal to, so it's up to but not including. We good? Correct. The point, don't confuse the point being included. The point is on the graph, but it's not increasing or decreasing at that point. It's increasing to decreasing. All right, let's go to the next property. The next property is going to be continuous or discontinuous, and this one is pretty obvious. What does continuous mean to you? Versus I didn't. You just weren't here when I started, so you thought it. Was that this class? The ambulance? Was that this class or was that? It was okay. That was pretty continuous. Anyway, if there's a break in the curve, it's discontinuous. The only curves you would have seen last year that had discontinuities were the ones that had vertical asymptotes or that had restrictions on their domain, right? But technically, the root function, which has restrictions on the domain, is still continuous because there's no breaks in it, but it starts somewhere. There's a difference between finite and infinite, and then continuous and discontinuous. You guys know the difference between finite and infinite? Yeah? Yeah. There's a beginning and an end to something that's finite, something that's infinite. There's no beginning or end. It's just boundless. Like my hunger for knowledge and protein. You might think I'm done, but I'm not done. I'll finish it. Okay, so would you say that these functions here are continuous or discontinuous? Discontinuous, and there are locations for the discontinuity. If you were to describe the location of the discontinuity, do you think you should describe it using the x value of the location or the y value? Why? They do. So why would you describe it using two y values instead of just saying, you know what I'm saying? Good guess, though. I thank you for participating and trying. Okay, so that's pretty much it. These are all discontinuous functions. You know the parent functions that are discontinuous? This one you haven't seen yet, but you'll see it this year. And it looks complicated. It's not. What? We good? All right. So next is even versus odd functions. What we have here are two even functions and two odd functions. So how would you describe the way these look? Look at the even functions. They have symmetry, I would agree with you, but symmetry is based on a specific feature, if you will. Yeah, it is a mirror image. So the graph is a reflection. One half is a reflection of the other. Where's the mirror located? It's on the y-axis. If you have a graph that appears like it's reflected in the y-axis, we would call those even functions. We good? All right. Can you think of another function that is an even function? It's one you learned about last year and the year before. A circle would work as long as its center is at 0 and the y value doesn't really matter. You understand what I'm saying? It is a relation, sorry, my mistake. So it would be an even relation. Can you think of a function that's even? Yes. Good. Good. Yeah, they took both of them, right? Okay. So you're ready to learn about an odd function. Okay. Whoop. These two are odd functions. No, but it looks like one branch from the tan curve, similar in shape. Did you say cube? It is a cubic function, the one in blue. The one in red is also it could be a cubic function as well, but it would have some transformations to it. Okay, so how would you describe the symmetry in these? Yeah? Ah, they're reflected, but they're reflected through a point. They're reflected through the origin. So it's almost as though it's been rotated 180 degrees. Rotated 180 degrees. Speaking of rotations, you ever had a rotato? A rotato? It's like French fries, except it's one. Yeah, you've seen it? Yeah. Where's that? Where did you have that or see it? Like a food market or night market? Was it in Ottawa? Navan? Okay. So they call them tornado fry or? Okay. Yeah, so it's one potato and they put it through, it's like a peeler slicer, and then they deep fry it and they sprinkle flavors on it. Swirly? Yeah. Anyway, they're pretty good. No? Do you like French fries? It's the same thing, guy. Okay, okay, I hear you. Listen, let's not hate on each other, okay? Because if we don't have each other, who do we have? Right on. Okay, and these are examples of neithers. You're like, wait a minute, that's a parabola, it's supposed to be even, and that's a cubic, it's supposed to be odd, but they're not. What happened to them? Yeah, they got translated. Now, if you take an even and you translate it left or right, it's no longer even. Do you understand what I'm saying? What happens if you translate it up or down? Still even? What if you reflect it? You reflect it, still even. And what if you stretch it vertically or horizontally? Even Steven. So even functions, if you just translate them left or right, they lose that evenicity. That's a made-up word. Yes?
Question, do odd functions have to, does the origin have to be, does it have to be, around the x-axis?
It has to be both, because it's the origin. It has to be through the x-axis and the y-axis at the same time. You know what I mean? So then it becomes through the origin. Choose. So if this is a cubic function, what transformations will not change it from being odd? Or maybe you want me to ask you which ones do change it and make it not odd. Do you or do you not want to not buy a new car? Yes, you can't. The timing was perfect, wasn't it? Hey, where's your phone? I's. So, yes, I don't, right? Yes, you can't. So, what transformations? Translation where? Left, right? Will cancel? Or will make it no longer odd? If you go left or right? Say again? It will, if something is odd to begin with, and you translate it left or right, it will no longer be odd. Is that what y'all are saying? I agree. Up or down also? Agreed. It's not going through 0, 0 anymore if you go up or down. You understand? See, this one went up 1 unit. It's not odd anymore. It's got to be rotated like a rotato or a tornado or a Twizzler potato about the origin juice. You get it? This one's not rotated about the origin. You could say it's rotated about the 0.01, but that's not the origin. Cool? What about stretches and reflections? Will they change? No, they won't, because you apply rotations and stretches, or reflections and stretches, before you apply translations. So reflections and stretches vertically or compressions horizontally will not change it from odd to even or neither. It'll still be odd if it started as odd. Okay, so we've got those 3 options. Now how much time we have left? 26 minutes? Is that about right? That's why I'm asking. Okay, so let's do our quiz, and we'll continue this tomorrow. You can.
I didn't know if I could.